ExemPoser. Predicting poses of experts as examples for beginners in climbing using a neural network. We present ExemPoser, the system to help beginners to learn proper stationary poses in sport climbing. In various sports, imitating poses of experts improves greatly players' skills. Sport climbing is no exception. First, we introduce what is sport climbing. The rule of sport climbing is very simple. The task of climbers is to climb a wall to reach a goal. The only limitation is that climbers can only use the set of holds determined for each course. To reach a goal, climbers should take poses which they use as little muscle power as possible or which they do not fall off the wall. We could find the example of good poses or bad poses in online videos. This is a bad example. He is bending his arms, so needs more muscle power. On the other hand, in good example, his arms are stretched. In this way, beginners need to learn proper poses for given holds. However, there are many courses in the world. Beginners need to observe experts' poses for each course. Although experts are not always with us, we could watch the video in which experts climbed each course, recorded by system like a beta cube. However, this system costs a lot in terms of resources of experts, since climbing courses are not only different for each gym, but also change regularly. For this reason, we want to help beginners in sport climbing to know proper poses for holds in front of them. This is our motivation. Then, we present ExemPoser. ExemPoser is the system which simulates what pose experts take for the holds the climber is now using. This is realized by a neural network. First, a video of a climber is captured by a fixed point camera from behind. In the moment of the climber being stationary, the climber's body joints are calculated from the image using open pose. The positions of hands and feet are extracted from body joints, and the neural network receives these positions. The neural network predicts the positions of other joints. Finally, by combining these joints, we could simulate experts' pose for given holds. We consider our system could be used as a smartphone application. Climbers can use the application for review or advice. Besides, we expect that suggesting predicted poses to climbers using a visualization system such as ClimbVis could further promote beginners' skill improvement. To realize these applications, our system has two features. First, our system has real-time performance. Second, our system allows arbitrary distance between wall and camera. So, users do not need to take care of the position of camera. This is our system overview. First feature is enabled by the neural network. Input layer has 8 dimensions, and output layer has 20 dimensions. We adopted a simple fully connected neural network. This kind of network is generally lightweight and low latency. Second feature is enabled by our preprocess. Because the distance between the camera and the wall in the video is unknown, if these body joints were shrunken at the predetermined ratio, the real distance between the holds could not be considered. Then, we consider the distance from neck to mid-hip of the body joints is almost the same in real scale. Therefore, we shrink the body joints in a video at the rate at which the average of the distance in the video become a certain size. As a dataset, we prepare the videos of experts climbing. 79 courses are respectively climbed by experts. And all videos was captured from behind. From all frames in the videos, we extracted only stationary moments. About detailed algorithm, please refer to our paper. This is the process of training the neural network. To train the neural network, we divide body joints in training data to input joints and output joints. This figure shows the prediction results in test data. The poses in the top are the actual expert poses, and the poses below are these predicted. Next, this figure shows the prediction results in beginners' data. The red line indicates the poses of the climbers, and the green line indicates the predicted poses. Some of them looks similar, but others looks different. To verify that the poses predicted by our neural network are appropriate examples for beginners, we conducted a user study targeted at expert. In our user study, experts compared pairs of poses like this figure. One is a predicted pose, and the other is a beginner's pose. And we're asked the question, which do you think better pose? They selected their answer in 5 scale. They didn't know which is a predicted pose. We asked 4 experts about 7 pairs. This figure shows the experts' answers to each pose pair. From this results, we can say that experts think the predicted poses are better than those of beginners in most cases. Experts gave us comments about these poses. For pair 0, experts said, in the predicted pose, the center of gravity of the body is placed on the vector of the hand-hold direction. For pair 5, experts commented, in the predicted pose, the body remains on the right side in spite of the hand position being on the left side, and the body is shaken and is not stable. These comments will be useful for future work. Our approach has some limitations. First, our approach does not account for the characteristics of holds. There are many types of holds in climbing, and it affects on poses in climbing. Although the courses in user study have few difficult holds, we consider this effect in future work. Second, our model only accepts 2D data and only supports almost right-angled walls. This is because we assume users use RGB camera. If we could capture 3D data, we could easily extend our system to 3D data. Finally, we consider that our system can be easily applied to modeling expert poses in other sports. Since we used machine learning, our system does not require domain knowledge of the sport, unlike rule-based modeling. In conclusion, we proposed ExemPoser, the system which simulates what pose experts take for the holds the climber is now using by a neural network. Our system assumes that beginners will use it on their smartphones to know proper poses in front of them. Our user study showed that the poses predicted by our system were better than the beginner's poses in most cases.